So there was a question on how the summations over spatial dimensions are handled. And to answer it, it's probably best to start out with the strong form. Okay, so I'm going to just talk about over I equals 1, 2, 3, right? Spatial dimension 3. Okay, so this is the question that I'm going to try and address. The way to start out with it, probably the best place to look at it is consider the strong form. Okay, and I'm not going to write out the entire strong form because I think we're all a little tired of seeing it too many times. Okay, strong form, just the PDE, right? Sigma ij comma j plus fi equals 0. Now remember, this holds for I equals 1, 2, 3. So really what this means is that, what does it mean? It means that there are 3 equations, right? 3 separate equations, and those equations, I'm going to write them out explicitly, are sigma 1 j comma j plus f1 equals 0, sigma 2 j comma j plus f2 equals 0, sigma 3 j comma j plus f3 equals 0. Now in each of these, when I say j comma j, there is a sum implied on j, right? Sum implied on j. That statement has got to be an irony, because the moment you put it down, the implication is no longer implied, right? It becomes an explication. So anyway, all right, so this is what we have. Okay, so when we look at the strong form, we really have three PDEs, right? 3 equations that are being solved independently, right? Each of them have to hold. The weak form, however, is different and you remember how we get to the weak form, right? Now in getting to the weak form, we say, how do we get to the weak form? Right, we take that same equation, sigma ij comma j plus fi, right, equals 0. We multiply it through by wi, okay, and now we're saying there's a sum on I and j, okay. In so doing, we have essentially collapsed the three equations that we started out with into one, right? The explicit form of that is, I'll write it out just once, and W1 sigma 1 j comma j plus W2 sigma 2 j comma j plus W3 sigma 3 j comma j plus W1 F1 plus W2 F2 plus W3 F3 equals 0. Right, that's what we're doing, and then we integrate this over the volume. Right? So here too, sum over j. Okay? And then of course we do integration by parts and so on, but observe that here too, even though we started out with 3 PDEs, we have collapsed them all down to a single weak form, right? A single equation, right? A single scalar equation, really. Okay? And then, of course, from here, when we go on, we do integration by parts and so on. What we end up with is a term where we have integral over omega wi comma j sigma ij dv equals integral over omega wi fi dv plus the sum over I integral over this wi t bar I. Okay. Now, the form of this is the following, the explicit form. It is integral over omega w1 comma 1 sigma 1 1 plus w1 comma 2 sigma 1 2, right, and somewhere along the line we come upon w3 comma 1 sigma 3 1 plus, until finally we come to w3 comma 3 sigma 3 3, right. There are 9 terms in here. Sorry, yeah, 9. Okay, 9 terms in here. dv, okay, equals the first term on the right hand side has how many? 3. w1 f1 plus until w3 f3. Okay, and then this nettlesome term involving the sum, right, over the Neumann boundaries. I'm going to write it over here because I need a little room. Okay, so that is integral over partial omega t bar 1 w1 t bar 1 ds plus integral over omega t bar 2 w2 t bar 2 ds plus integral over the third Neumann boundary subset w3 t bar 3 ds. Okay, and the key is in this case that each of those boundary subsets could be different. Okay, so over each of them, I mean, clearly there's no sum implied here, right, because I've written everything explicitly. Okay, so over each boundary subset, you're only integrating its corresponding components multiplied. Okay, so, all right, so that's how it works. So the weak form is a single equation, unlike the strong form, which is 3.